have a system of 3 rods which have been welded at their ends to make an equilateral triangle, and the mass of each rod is m and length is L, and the mass is uniformly distributed. We are asked where is center of mass or center of gravity of this system of 3 rods. To make the thing slightly asymmetrical, let's take it as 2m instead of mass m. So we have mass m, length L rod, mass m, length L rod. This is mass of this rod is 2m and length L. We are asked where is the center of mass or center of gravity of this system of 3 rods. So what we do over here is, we see that is because this is uniform mass distribution system, so its center of mass or center of gravity is halfway, midway. Similarly, center of gravity is midway, center of gravity of this rod is midway. So this is equivalent to a system if we say, that is, if we have a particle over here, if we have a particle over here, if we have a particle over here instead of these 3 rods. So it is going to be, so over here we can assume its whole mass to be concentrated over here, we can assume its whole mass to be concentrated over here, we can assume its whole mass to be concentrated over here. So if we say this mass is m, length is L, so its coordinates, if we take this as x-axis, this is y-axis, and this is origin. So its coordinates, they are going to be obviously L by 2, 0. They are going to be coordinates. For this, if we say if total mass is m, length is L, so from here to here is L by 2. This angle is 60 degree. So x coordinate is going to be L by 2 cos 60 degree, and y coordinate, this L by 2 cos 60, L by 2 sin 60, so L by 2 sin 60 degree. So this is going to be x and y coordinates of this rod of mass m and length L. Now coming to what are the coordinates of this. The coordinates of this, once again, because this is L by 2, so this is going to be L by 2 cos 60 degree, and this y-axis distance, this is going to be L by 2 sin 60 degree. X coordinate is not going to be L by 2 cos 60. It is the distance of this from the origin along the x-axis. So this is this much. What is this distance from here to here? The distance is total L, total length is L, and this from here to here is L by 2 cos 60, and we are interested in this. So x coordinate is L minus L by 2 cos 60. So its coordinates, they are L minus L by 2 cos 60 degree. This is x coordinate of this center of mass, and y coordinate is remains same, that is L by 2, that is L by 2 sin 60 degree. Rest is now simple. So this is eventually over here, if we call this point A, this is point B, this point C. So it is like, this is x-axis, this is y-axis, this is origin. We have one is over here, A with these coordinates, C is over here with the coordinates L by 2, 0, and B is over here with these coordinates. So this is a 3-point mass system, and we know that is how to find the center of mass or center of gravity of this system. That is xcm is going to be m1x1 plus m2x2 plus m3x3 over m1 plus m2 plus m3, and if you put the values, so xcm, or what we call as x bar, is going to be m1x1, m1 of this mass. How much it is? This is m, and what is x? This is L by 2 cos 60 degree, plus this work is done, job is done. Now coming to C, that is m, m2 into x2. x2 is what? L by 2, plus coming to this one, that is 2m. Now its mass is 2m. What is x coordinate? X coordinate is, we had calculated L minus L by 2 cos 60. L minus L by 2 cos 60 degree over, we have to take the whole mass, that is m plus m, m plus m plus 2m. So from here we can find the xcm. Similarly, using the formula ycm is equal to m1 y1 plus m2 y2 plus m3 y3 over m1 plus m2 plus m3, we can find the ycm.